So let's look now at verifying trigonometric identities. And what we're going to do now is we're going to verify identities using all of the rules we know from algebra, as well as our fundamental trig identities to rewrite and simplify expressions and equations. And an identity is proven when the right side of the equal sign is equal to the left. So we're trying to get both sides to be the exact same. So let's look at this, and we're going to do a bunch of trigonometric proofs using identities. Let's look at this first example. We're trying to prove 1 minus cos squared theta over cos squared theta is actually equal to tan squared theta. And we're going to do a proof, and we're going to do a two-sided proof. And what a two-sided proof is we consider the equal sign the separation between our left-hand side and our right-hand side. Here's our left-hand side and our right-hand side. And what we're going to do is we're going to show that the left-hand side equals the right-hand side. And we're going to do this using our trig identities. So we have to always try and simplify the most complex side first. And that's the important piece, and that's the key. Always start with the complex side. The more complex side is actually going to be easier to simplify. So we're always going to start with the side that looks more complex. Well, it's pretty easy to see here a fraction is a little more complex than a single term, so we're going to try and simplify the left-hand side. So what we have to consider is identities, and there's one identity that hopefully you can see right away. We have a 1 minus cos squared theta, which we can really just change to sine squared theta. Haven't done anything to the denominator, so we still have cos squared theta. Now that simple change actually helps us find the right-hand side, because sine squared theta over cos squared theta is really just tan squared theta. Now the left-hand side actually now equals the right-hand side. And there's our proof. This is a pretty easy one, just takes one identity. Our left-hand side equals our right-hand side, and we can make that final statement that the left-hand side equals the right-hand side. And there's a very straightforward two-sided proof. All we're doing is changing identities to get one side to equal the other. Now, not all proofs are going to be that simple. Let's look at one that's a little more complex. 1 plus tan theta over secant theta is equal to sine theta plus cos theta. So let's set up our left-hand side, right-hand side, and we have to decide which one is the more complex side. Probably the fraction is more complex, but the key to this kind of proof is we don't have any squared identities, no Pythagorean identities. So when that's the case, we're just going to take all of our values and change to sine and cosine. Change everything to sine and cosine. And this is going to make the question a little bit easier. So we can say we have 1 plus tan theta is the same as sine theta over cos theta. And the denominator is 1 over cos theta. Now that's our first step. Well, now what we can do is we can simplify this. Well, we can take our numerator and create a common denominator of cos theta, which means we're going to get cos theta plus cos theta, that's the 1, plus sine theta over cos theta. And again, when we're doing a proof, we must show everything. And all of that is over 1 over cos theta. All right, let's keep going. Now we get this point. We can combine the numerator into a single fraction, and we get cos theta plus sine theta all over cos theta, and that whole thing is 1 over cos theta. Now when we're doing a proof, what we always want to consider is what are we trying to get? And we're trying to get sine theta plus cos theta. And if we look down at our proof, we have cos theta and sine theta added together, which means we're on the right track Well, let's keep going now. We have a fraction divided by a fraction. So really we have cos theta plus sine theta all over cos theta. And remember, when we have a fraction divided by a fraction, we multiply by the reciprocal. So we'll get cos theta over 1. And at this point, we now can cancel out the cos thetas. And what we're left with is cos theta plus sine theta, which is exactly what we wanted. And that, if we bring down our two-sided proof, is equal to sine theta plus cos theta. So the left-hand side equals the right-hand side. And this notation of left-hand side equals right-hand side tells that our proof is complete. So we need to make that statement. There's a variety of other ways we can make statements, but we often say left-hand side equals right-hand side, and our proof is complete. So this proof is a little more complex. There's a lot of steps, but again, we must show all those steps. And it's often easy to see whether a proof is going in the right direction because we always know what we're trying to get towards. So we're going to do a number of proofs like that in class, and they're going to get more complex. We're going to use all our techniques from the previous section to simplify left side and right side so they're equal to one another.